Good afternoon, everyone. Welcome to Creative Online Weekend Talk of episode 176. I am your host, Supriya Nayaka, MK, and it's my pleasure to have you all join us today. At Creative, our vision is to bring constructive thinking across various domains. We focus on non-textual, non-academic, non-syllabus related concepts, and we encourage discussion that go behind conventional learning. As a registered trust, we are committed to forecasting intellectual exploration by inviting experts who inspire curiosity and innovation. Today, we explore an exciting scientific topic, structure and property relationship in polymers. Our esteemed speaker, Dr. R.L. Jagdish, is a retired professor from the Department of Polymer Science, University of Mysore. With a distinguished career, he has served as a resource person in over 250 programs, written Kannada science articles in various magazines, and contributed scripts for documentaries. His expertise in polymer science will help us understanding how molecular structure influence material properties, an essential concept in science and technology. Creative organize online weekend talks on every Saturday around 3 to 4 p.m. on Zoom platform, and also we live stream our program on YouTube, our YouTube channel Creative GBD. So feel free to revisit this session and you can share with the groups. Okay. I welcome one and all for this session, and I welcome Jagdish sir for today's session. Over to you, sir. You can carry on. Sir, you can unmute yourself. Yes.
Okay.
Yes, sir. Thank. Go ahead, sir.
So, good afternoon, everyone. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಮೊದಲನೇ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ನೀವು ನೋಡ್ತಾ ಇದ್ದೀರಾ ಮಾರ್ಟಿನ್ ಕಾರ್ ಪ್ಲಸ್ ಅಂತ. ಸೊ ಹೂ ಇಸ್ ದ ಪರ್ಸನ್, ಎ ಗ್ರೇಟ್ ಅಮೆರಿಕನ್ ಥಿಯರಿಟಿಕಲ್ ಕೆಮಿಸ್ಟ್. He was the Theodore William Richards Professor of Chemistry at Harvard University. You can see in the slide. My intention is to highlight he was born during March 15th, 1930, and he expired during December 28, 2024, recently. And his contribution is about the retinol, which is also known as retinaldehyde. You can see the molecule is a polyene chromophore. As you know, what do you mean by chromophore? Retinol bound to proteins called opsins is the chemical basis of visual phototransduction, the light detection stage of visual perceptions. That is vision, how we see things. Similarly, on this day, March 15th, Sidgwick, who died on 15th March, he was also a theoretical chemist, and I am interested because he contributed towards valence theory of chemical bonding by explaining the role of valency in covalent bonding, and also he demonstrated the existence and importance of the hydrogen bond. So hydrogen bond is the most important aspect in most of the polymer chemistry. And as we know that we allow, it is just a chemistry. So scientists usually push chemistry to help us go faster, farther, deeper, and higher. And before everyone get into the seriousness of this, I just want to tell you about what difference is one bottle going to make ಅಂತ. ಈ ಮದುವೆ ಮನೆಯಲ್ಲೆಲ್ಲ ನೀವು ನೋಡಿರ್ಬೋದು, ಲಕ್ಷಾಂತರ ವಾಟರ್ ಬಾಟಲ್ಗಳು ಜನರೇಟ್ ಆಗುತ್ತೆ ಒಂದು ದಿನಕ್ಕೆ. ಒಂದು ಮದುವೆ ಅಂತ ಅಂದ್ರೆ ಮಿನಿಮಮ್ 2000 ವಾಟರ್ ಬಾಟಲ್ಸ್ ಆರ್ ಜನರೇಟೆಡ್. ಸೊ ನಾನು ಒಂದು ಬಾಟ್ಲು ಆಚೆಗೆ ಎಸೆದ್ರೆ ವಾಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್? Similarly, the trash or the garbage which goes out of us. This is the billboard I see in Sonitpur when I was traveling there. Similarly, here again, what is the point of your education if you still throw garbage on street to be ultimately picked by an uneducated person? And this is the main drawback in all the cities throughout the world. ಯಾವುದೇ ಊರು ತಗೊಳ್ಳಿ, ಗಾರ್ಬೇಜ್ ಕಲೆಕ್ಷನ್ ಅದನ್ನ ಮೇಂಟೈನ್ ಮಾಡೋದೇ ಬಹಳ ಕಷ್ಟ. ಲಕ್ಕಿಲಿ ಗ್ಯಾಂಗ್ಟಾಕ್ in Sikkim, they have got a beautiful system and they clean their places. So chemistry you have seen, we have alcohol, caffeine, adrenaline, chocolate, love, and happiness. So hence chemistry is always awesome. So the main important class of chemical in chemistry is benzene. Before that, I had a call from one of my friend in Mumbai Customs. So he called me and asked me to how to identify the virgin polymer, for example, polyethylene, and any used polyethylene, how to examine it, how to find out whether this is virgin or not, because both of them look very similar when you just look into it visually. Visually, you can't do anything there. So I was thinking what to do with that. So whenever a polymer is used as a chemical, whatever you use, especially polymer, you have to heat to process the polymer. So when it is heated, and when it comes to recycling, there will be some sort of degradation products or decompositions. So what do you mean by decomposition? So again, whatever the polyethylene structure may get damaged, and while transforming into product, and where the recycling comes, maybe some different types of structural matter may be there in polyethylene. For example, polyethylene is CH2, CH2, CH2 molecule simple. So on degradation, there may be chances of CO also there. So if you just go through the molecular formula and check in gas chromatography or any other thing, you can find out the degradation products in that, and you can definitely say that. So this is degraded, or this is not the virgin polymer which you have been supplying. So people deceive everyone these days. As you know, they sell recycled polyethylene or recycled any polymer and say that this is virgin polymer. So these some of the tests which have been done by our chemists will ensure that the pure molecule will not have any degraded products. Similarly, you might have seen of suppose you have a plastic buckets, plastic mugs, or anything which is made up of polymers uh, outside, which is exposed to environment. You might be observed in some cases, if you have a colored bucket, for example, red color or blue color or any other color which we like. So there will be chances of bleaching of the color in the sunlight, that to UV and exposes to moisture and oxygen. So why there is a color change? We had a uh, doubt. Why should the color changes? So here in the initially in slide I told you about chromophore. So when there is a action of UV light or the heat on the polymer, there is a chances of degradation or molecular changes. As the molecular changes, the chromophore which exists on the in the polymer molecule will change. As the change occurs, definitely the chromophore properties will change, and ultimately you will get bleached materials. That is how we segregate the polymers when it is in the material sections. Hope you understood that. So whatever it may be, if there is a change in color, for example, you consider the tires. Tires in automotive sector, we have enough tires throughout India and throughout the world. Lots of chemicals are being used. Chemicals, additives are being used to make the tire beautiful and the best one. For example, you can see here this one. You can see I'm showing you the picture of a tire section where you can see this is the tread portions. So people think the tire is a single entity like that. It is not like that. Tire is being built by with different materials. So this is a highly dynamic product. So dynamic product also starts getting cracks perpendicular to the rotation of the tire. So that may be the due to the breakage of some of the molecular bonds in the original polymer which has been used. So nowadays you might have seen that they ask you to fill nitrogen into the tire whenever you take the vehicle to the uh, petrol bunk or anybody who serve the vehicle with the air. So we always prefer nitrogen. There is a simple concept in that. As such, nitrogen is a bigger molecule than oxygen, which is the major component in the air. So air contains all sort of things. It may contain impurities, moisture, nitrogen, carbon dioxide, other things. But nitrogen is pure. So since the nitrogen molecule is bigger than oxygen molecule, so the permeability of the nitrogen molecule inside the rubber or the polymer which is used for the making is difficult. Hence, when you fill your tire or the tube, whatever tubeless tires or anything, the longevity of retaining the nitrogen will be ಹೆಚ್ಚು ದಿನ ನೈಟ್ರೋಜನ್ ಹಾಕಿದ್ರೆ ಹೆಚ್ಚು ದಿನ ಇರುತ್ತೆ. ಇದು ಇರುತ್ತೆ ಮಾಮೂಲಿ ಆಕ್ಸಿಜನ್ ಇರೋ ಏರ್ನ ನಾವು ಪೆಟ್ರೋಲ್ ಬಂಕ್ ಅಲ್ಲಿ ಹಾಕಿಸಿದಾಗ 1 ವಾರದವರೆಗೆ ಅದೇ ಇರುತ್ತೆ. ನಂತರದ 1 ವಾರದಲ್ಲಿ ಒಂದು ಏರು ಉಳಿದಿದ್ದೆಲ್ಲ ಆಚೆ ಹೋಗೋದ್ರಿಂದ ನೈಟ್ರೋಜನ್ ಮತ್ತೆ ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಸ್ವಲ್ಪ ಉಳ್ಕೊಂಡು later stages another 1 week the tire pressure will remain same. Suppose you put nitrogen itself, that will have a better aspect as far as the tire is concerned. Tire is always called as a dynamic product. I have given you the structure of benzene here, and we all fascinated by the molecule benzene. Whenever benzene is incorporated in any of the polymer chain, it induces stiffness. For example, you take polystyrene molecule. In polystyrene molecule, when you introduce benzene ring, it becomes very stiff. Hence, polystyrene is highly brittle. It cannot bend. It cannot be soft. It cannot be. It has to be like that only, because as you know that the resonance rules says that benzene loses its aromaticity if it doesn't keep the planar structure for itself. Planar ಇರಬೇಕು. planar ಇಲ್ಲ ಅಂತಂದ್ರೆ ಬೆನ್ಸಿನ್ ಅದರ ಪ್ರಾಪರ್ಟಿ ಕಳ್ಕೊಳ್ಳುತ್ತೆ. So there is again a reason for that. Whenever you talk about benzene and the ring inside, you can see the PZ orbitals which I have shown there. There will be overlap of p orbitals. So the overlap is possible when the whole molecule is planar hexagon. If it is not planar, there will not be overlap possible. Hence, benzene loses its aromaticity. Hence, wherever you take the benzene, it becomes very stiff. And of course, polystyrene has got its Tg around 100 degrees centigrade. Tg means glass transition temperature, where the molecule, polymer molecule, becomes soft, because you cannot give just temperature for any of the polymer molecules. So these are some of the quotations by famous scientists. So the world would be totally different place without artificial fibers, plastics, elastomers, etc. Even the field of electronics. When you talk of electronics, we'll talk of insulations. Insulation is the most important aspect of in electronics. And now, after 2000, we have come across organic electronics and conducting polymers. So that is also, I can't say that all the polymers are insulators. So that is a misnomer right now. Future, it is mixed. Now, insulation ಆಗೂ ಉಪಯೋಗಿಸಬಹುದು, ಅದನ್ನ ಕಂಡಕ್ಟಿಂಗ್ ಗೋಸ್ಕರ ಉಪಯೋಗಿಸಬಹುದು. After the 2000 Nobel Prize of conducting polymers, we had enough products using organic materials. Similarly, the complexity of the structure and behavior of the tire are such that no complete and satisfactory theory has been proposed. So, this is the mechanics of pneumatic tires. They have quoted this. So the concept, the people may think very lightly about the tire, which carries the load, which takes up the braking, and it can maneuver any roads, even non-tarred, non-bituminated roads and all. Still, people should thank the tire because it takes lakhs of kilometers. So that is the dynamic property of that. Similarly, see about rubber-like materials, they are always interdisciplinary in nature. Physics, chemistry, metallurgy, dynamics, tribology, thermodynamics, heat transfer, elasticity, viscoelasticity, rheology, elastohydrodynamics play complex and intervene roles in determining the magnitude of frictional coupling that ultimately exists the contact patch. This is the one which I say the contact patch, which comes to the road like this. So again, the polymer chemistry and physical characteristics determine properties and performance of any materials. So one more important aspect has been effectively observed and noticed by a scientist known as Weisenberg. So was an Australian physicist known as Carl Weisenberg. So here you can see the pictures. Whenever you just stir a regular solutions, not polymer, regular solutions, there will be dip. When you stir something, that there will be a dip. Whereas in case of polymers, whenever a polymer solution is stirred, usually the material goes up. The polymeric material or the solution, the polymer, the solution, the polymer in the solution will usually, we call it as reptation, where the polymer molecules will entangle and rise. So this is one of the important aspect which Wiesenberg has mentioned. So coming to, there is a concept of vulcanizations. As you know that rubber vulcanization is a very familiar aspect whenever we talk of tires and or any other product. There are good number of products available in the market using a small o-ring to anything, you know. So here you can see the sulfur is the best known chain linker. You can see in the picture how the chains are linked by sulfur. So sulfur carbon linkage has got a resistivity towards heat. Resistivity towards, hence sulfur is the most preferred material for vulcanization and linking carbon-carbon chain. The structure what I have given is the natural rubber where you can see CH3 and double bonds. So ebonite is a material which was manufactured using higher proportions of sulfur, and it used to become very hard. So I have a sample of ebony, which is very popular in England. This is the what you call wood. Ebony is a wood, and it is so hard as metal. Hence, the material which has been manufactured like this was called as ebonite. So initially, you might have seen some 30 years back, they used to find battery boxes made up of ebonite, which used to be too much of weight because of the sulfur linkage. We are using 25 to 80% of sulfur and linseed oil as a mixing agent to manufacture or to prepare ebonite, and that used to be molded to get the beautiful battery boxes where the batteries being it is used to make batteries. Similarly, the celluloid, The name celluloid came into existence because the films are being used in movies. Hence, that is why we call it as celluloid world. And as you know, that cellulose itself was not able to convert into anything unless it is a used as a fiber. It could not be used for any other purpose. So people started experimenting with that, and later they converted cellulose with nitric acid into cellulose nitrate. If the amount of nitric acid is less, then you get cellulose nitrate. If the amount of nitric acid is very high, then you get a detonator, nitrocellulose. So nitrocellulose is very dangerous to handle. And later they used camphor to mix it and then mold it. So you might have seen lots of what to call the elephants were killed to remove their teeth, or what you call that. I forgot that. So the ivory, ivory. So hence what the scientists did, they made a exactly ivory color in celluloid, that is cellulose nitrate, and it was very tough and flexible, and it was used in various other aspects and materials also. The major aspect was to give a one of the what you call equivalent to ivory, which is being brought from killing elephants. So this is the cellular nitrate. You can see that, and the camphor. Camphor used as a plasticizer in making cellulose nitrate moldable. Otherwise, it is difficult. For example, when you do chapatis or roti or anything, you need to add water or oil to make it very soft. So here also the same thing happens with cellulose nitrate. Similarly, cellulose xanthate also prepared. And I have one example for, you can see that. So this is the one polycarbonate material. You can see this is completely clear. You can see me in this. So this is the one which is used for making bulletproof materials for police and the army who fought with the enemies. And you can see that. And this is the sample of the bulletproof material. So major component is polycarbonate, and this is a sample of the bulletproof material. And you can see how it works. Bulletproof material poly, the glass is not elastic. So all of the energy from the moving bullet is taken by the glass, which exceeds the fracture strength of the glass, causing it to shatter. So here they use polycarbonate, and hence the energy from the bullet is absorbed. That is, the kinetic energy is dissipated in the molecular structure. You can see here the carbonate group and the benzene. So benzene is very stiff. I already told you. It is an engineering plastic, and you have a carbonate group. Because of the carbonate groups, you have hydrogen bonding, you have more electrostatic charges available in the molecule, and hence it has got a high impact strength. Polycarbonate has got a high impact strength, hence that is used even mixie lids and components for making some bulletproof applications. Even when our Prime Minister speaks on the occasion of August 15th, there will be high security bulletproof material which used. So the major aspects in bulletproof material is the benzene ring. So benzene ring we and the poly and the carbonate group which is there, and make it very high impact strength and high dimensional. So it doesn't lose the dimension even it is hit by bullet also. And you can see here, so this PBI has got the high decomposition temperature of 660 degrees centigrade because of the presence of these groups. You can see the whole molecules which I have shown you going have conjugation effects. So due to conjugation, the molecule becomes very, very stable. And again, polyamide, the molecule has got the working temperature of 585 degrees centigrade. Imagine an organic compound works at 585 degrees centigrade, and you can see the structure, complex structure of the molecules, how it has been made. We use a diamide unit and polyamic acid and polydiamide unit to make this. Similarly, when I visited Malaysia, so I was able to make into the University Technology of Malaysia, where the students work with all the molecules. So they were working on the sulfonated tetrafluoroethylene uh, based fluoropolymer copolymer. So they used to make this, use this to make some of the water purifying equipments. So here the combination of the stable polytetrafluoroethylene backbone with acidic sulfonic groups gives Nephon its high characteristics. You can see here polytetrafluoroethylene backbone is interlaced with ionic sulfonate groups, and Nephon is one of the major molecule which is used for purification of water. So here you can see again we have PET and polyethylene terephthalate. You should remember we have seen PET bottles. So usually whenever they make PET bottles or any bottles like that, you should have a high melt strength. You should have melt strength because in seconds it is going to melt and it has to solidify. So solidification and melting very, very fast. So polyethylene terephthalate is known for such purposes. So again, they have made polybutylene terephthalate also. So some of the properties change with the PBT, and you can see the structure. So they are go on changing methylene CH2. We call it as CH2 as a cute group, methylene group. So whenever there is a methylene group in some of the polymer molecule, they usually make it more flexible. For example, polybutadiene. Polybutadiene, you might have seen um, the balls which are used for uh, ping pong balls, or you call it as magic balls. So if you just leave the ball from some height, so it goes double the height. So that is usually made by polybutadiene material. So this polybutadiene material has got a double bond and also methylene groups. These methylene CH2 groups are very much influence the property. ಇದು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನಿಮಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ PET, PTT and PBT. So they assume structures like this so that the property increases like anything, either PET or PTT or PBT, and the intermolecular forces are also minimized. So that is what the structures. You might have seen polyethylene. You might have heard of polyethylene also has got little bit of twisting of its chains so that it has got also good equivalent, the good forces available for chains to be together. Just PTA, PDO, chemical structure of polytrimethylene terephthalate. So you can see here they included two carbonate groups and methylene groups. So this is used for most of the what you call fibers, fabrics. So as we already discussed, we have thermoplastics, thermosetting polymers, and fibers. So all these materials have different properties due to their different structures. Okay, coming to So PTT fiber is said to have the natural and comfortable hand feel, good tension, elasticity, aid at low temperature. PTT fiber also has high washing fastness and good anti-static performance. So what the nylon is giving, it is giving more than, it combines the advantages for nylon elasticity and softness, as well as the acrylic fiber fluffy and polyester anti-pollution. It not only can be widely used in clothing and other textiles, but also has a great potential for market. So this is the structure of nylon. You can see here, I have some bristles of nylon, which are used for the purpose of the toothbrushes. Toothbrushes are usually made by using this nylon fibers, because nylon fibers are they are not going to harm either the teeth or the surrounding muscles or anything. They are not going to harm. Hence, so usually we have to change the toothbrushes as soon as they lose their strength. That is the bend. So bending is due to the absorption water, because nylon has got CONH. You can see here CONH. When there is CONH, water or the moisture definitely can hydrogen bond with these molecules. And here what I am showing is about the airbags. So as you know, all of you know that almost all the airbags. So there are a lot of fabrics available to make airbags. But here the airbag is being made by nylon only. So I may ask why nylon is the material used, because nylon, most common fabric used to weave airbag cushions for general manufacturing and automotive applications, because the fiber made of nylon has got a rapid inflammation, because as you know that in few seconds, as you know that I have got the sample here. So this is the one you can see here, and this is where we have the styrene, and this is the nylon. So the sensor will trigger from here within seconds, and you might ask why nitrogen, since nitrogen is inert. Hence, they release nitrogen. I'll show how nitrogen. This is the one I showed you, how the airbags open. Azide. Sodium azide is within 50 milliseconds, nitrogen gas is liberated. So this is the crash sensor is the outside. There is an inflator, and nitrogen gas is liberated in such a way that the airbag is filled with nitrogen within 50 milliseconds before the impact produces any damage to the person who is driving. Hope you understood this. This is the concept of using this nylon fabric for the purpose. You can see that. The same material is used for parachutes also. So wherever the paratroopers land, so it beautifully works. And only recently we had an accident where it doesn't open. So that was the different case. But as far as the uh, paratroopers are concerned, the parachute made by nylon, now they are going for a different type of fabrics. So nylon is used as a fabric. Nylon is used as a fiber, fabric, fiber. Nylon used as a thermoplastic also. As you know that Nylon after processing. I think you have understood all polymers are processed. Processing is most important. I told you, cellulose is converted into cellulose nitrate and it is processed. As such, it cannot be processed. So hence they use camphor as a plasticizer. Plasticizer ಅಂದ್ರೆ ಅವಾಗಲೇ ಹೇಳಿದ್ನಲ್ಲ ಆಯಿಲ್ ಈ ತರ ಅದನ್ನ ಹಿಟ್ಟನ್ನ ಬಹಳ ಸಾಫ್ಟ್ ಮಾಡುವಂಥದ್ದು. ಲೈಕ್ ದಟ್ ಕ್ಯಾಂಫರ್ ಇಸ್ ಯೂಸ್ ಫಾರ್ cellulose nitrate to make it moldable. So hence the ivory white material comes into picture there, and we have cellophane, cellulose acetate, cellulose monoacetate, cellulose triacetate. And there are a lot of cellophane, a lot of materials came after cellulose is able to process it through different. Similarly, we had rayon. Cellulose was converted into rayon using carbon disulfide. So rayon is also most important material. Till 1990, rayon was used in the tire industry, and rayon was used as a fabric also because of its shrinkage problems. Why shrinkage? Because it is a cellulosic material able to absorb moisture. You have to keep large area to keep them warm and see that the moisture won't be absorbed by rayon. So later rayon was discarded and people have gone for nylon, which was a better material. Now we have polyester. Even polyester also, they had some problem. Now we have come to radial tires where we use steel wires. So totally the fabric usage was limited to some places other than major tire parts. So stainless steel wires are being used, and wires are coated with rubbers. So that is a different aspect. So hence you should remember that here that nylon is the best suited for airbags. See, as you know that the tires are being tested. So that is why they encourage the Formula One car drivers to use their tires and see that. As you know that there are two aspects important for the tires. One is about the Formula One tire. Another is about the aircraft tires. You know, the passenger aircraft has been increased like anything. In San Francisco, every second flight lands and one flights goes up. In Bangalore airport or Delhi airport, there may be similar cases in future. There are number of people traveling. Hence, more safety aspects also been included in this. So as far as the Formula One tires are concerned, they have to run the vehicle almost up to 600 kilometers per hour to win the race. So there is always a chances of tire getting burst or lots of things, and we have a cabinet. You can see there is a armor panel or where the person sits inside for the driving. So there a material known as phenylene 2,6-benzoxazole is being used, which is also known as Xylon. So you can see the role of benzene molecule here. So you can see the person who is sitting, even the whole vehicle get degraded, not degraded, decomposed or any hit with something, and whole parts are being removed. Nothing happens to the person who is driving the car. So F1 cars. So it is going to, nothing going to penetrate into the cabin of the person who is driving, and it is going to protect him from getting injuries. So the Xylon is also used for, you can see table tennis bats where you need high pressures. Whenever there is high pressures, they use the racket. You can see the racket structure of the station, and you have Xylon used here. So not only Xylon is most important here, for the tire they use natural rubber. Natural rubber is being used for the purpose. I'll show the sample of natural rubber. So natural rubber is made by a latex, you can see. As you know that the natural rubber is obtained from Hevia brasiliensis. And as you know that natural rubber is cis polyisoprene. You can see this is the natural rubber, cis polyisoprene. And if you just say that there is only cis, no. Naturally, natural rubber trans is also available from the plant Jacta percha. So natural rubber is more preferred for these tires because of the impact strength. The natural rubber has got, there is no immediate replacement for natural rubber. We have plenty of what you call synthetic rubbers available in the market from various producers, from Exxon Mobil to any number of manufacturers. They produce all these materials. But the natural rubber, which is grown more in Kerala, and we get natural from Malaysia, Thailand, Indonesia, and all. So this natural rubber has got the unique property of high impact strength. So as soon as you think of F1 cars, the natural rubber property has to be remembered because the tires are being manufactured by that. Of course, the cabin is being made by Xylon. Similarly, we can see the strips where wet weather and all Formula One tires, street car tires will last for 50,000 kilometers. But Formula One tires are built for performance. So they have to perform. Sometimes they have to change the tire within one lap. Similarly, aircraft tires, which are known as structurally engineered tires in the world, withstanding pressure of 100 times that of a car or a truck tire. As you know that aircraft tires are also made by natural rubber only. You imagine aircraft landing with 3,000 ton weight. You imagine some 8 tires or 6 tires. Sometimes Dreamliner has 12 to 22 tires. So the whole thing takes up the complete weight of the aircraft while landing. So how imagine how the rubber material is going to help us to land very safely. The aircraft needs a long stretch of tarmac before the plane reaches the correct speed for lift to take place. So without wheels, it is not possible. So hence the structurally engineered Hevia brasiliensis, the rubber, is being used for this. So now I have come to the real aspects. ಅಂದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಪ್ರಾಪರ್ಟಿ ರಿಲೇಶನ್ಶಿಪ್ ಅಂದ್ರೆ ಏನು ಅಂತ. ಸೊ ಯು ಮೈಟ್ ಹಾವ್ ಹರ್ಡ್ ವಿಡಿಸೈಡ್ಸ್. ವಿಡಿಸೈಡ್ಸ್ ಅಂದ್ರೆ ಕಳೆನಾಶಕಗಳು ನೋಡಿದ್ವಿ ನಾವು. ತುಂಬಾ ಕಳೆನಾಶಕಗಳು ಉಪಯೋಗಿಸ್ತಾರೆ. ಈ ಕಳೆನಾಶಕಗಳು ಕಳೆನ ಮಾತ್ರನೇ ತೆಗೆಯುತ್ತೆ ಹೊರತು ಅವು ಬೇರೆ ಯಾವುದಕ್ಕೂ ಅಫೆಕ್ಟ್ ಮಾಡೋದಿಲ್ಲ. ಬೇರೆ ಯಾವ್ದಾದ್ರು ಭತ್ತಕ್ಕೆ ನಾವು ಹಾಕಿದ್ರೆ ಕಳೆ ಮಾತ್ರ ಹೋಗುತ್ತೆ, ಭತ್ತ ಹಾಗೆ ಇರುತ್ತೆ. ಸೊ ಹೌ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಅನ್ನೋದು ನಮಗೆ ಕ್ವಶನ್ ಇರುತ್ತೆ. ಸಿ ವೈ ಪರ್ಟಿಕ್ಯುಲರ್ ಡ್ರಗ್ ಈಸ್ ಎಫೆಕ್ಟಿವ್. ಸಮ್ಟೈಮ್ಸ್ ವಿ ಹ್ಯಾವ್ sustained release drugs irutte. A drug they inject will go to the particular place where the pain is there and they cure it. So why certain chemical toxic irutte? Why does a particular pest not break down in the environment? Yaak agbodu? Why does bulletproof vest work the way it does? It already uttara koಟ್ಟಿದ್ದೀವಿ ನಾವು. So here the total answer for this is the structure determine properties. It is a very powerful concept in chemistry. Not only in chemistry, in all fields in which chemistry is important, including but not limited to. So that we have not understood properly about why, how the structure and property are related. So that is what I told you. Already you have seen some of the materials where the structure makes everything. So you know what do you mean by a structure, the molecular formula, functional group. Functional group also important. Sometimes people doesn't know about what is the functional group. Functional group is the important aspects of any of the molecules which we either polarity or for example, you take the case of polyvinyl chloride, PVC. Polyvinyl chloride pipes and tubings are being used everywhere. Wherever there is a construction, they use UPVC. Then other type of CPVC, they use PVC pipes are being as an insulators or for electrical applications and all. That is because PVC is a flame retardant polymer. Because as it catches fire, the chlorine is liberated. As you know, chlorine is a good living breed. Either chlorine liberated or HCl liberated. This is going to block the oxygen coming towards it to help the burning. So hence PVC is the material which is used everywhere. Wherever you say, they use PVC for that purpose. So there you can imagine that the PVC can be definitely suggested for the flame retardant material applications. So molecular, as you know, that molecular structure, already I told you when the customs called me some 2 months back from Mumbai about testing, how to test this virgin polymer and used polymer. I told them about this, how to you check for degradation products in the particular molecule, help you to say that which is the virgin one. So because whatever used one will have definitely some degraded products in it. So when you heat something, definitely you get, because all polymers are going to char when you heat. So when you heat simultaneously work or extrude or anything you do it, there will be some sort of changes. Hence this X-ray crystallography, they are all going to examine and tell you what is happening there. So this is also most important, the arrangement of chemical bonds in atoms in a molecule or in an ion or a radical with multiple atoms. And that is about the structure. As all of you know about structure. Now, what is meant by properties? We have chemical properties. Reaction rate, position of, why does the SN2 reaction occur well on a primary center but not steric effects? Why trichloroacetic acid is 10,000 times more acidic than acetic acid? So as you know that Linus Pauling has written on electronegativity. He has written a book on electronegativity, he written a book on vitamin C. Usually say that vitamin C has to be consumed every day to have a better health aspects like ಈ ರೋಗ ನಿರೋಧಕ ಶಕ್ತಿ ಬರಬೇಕು ಅಂತಂದ್ರೆ ಅದು ಉಪಯೋಗಿಸಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಟ್ರೈಕ್ಲೋರೋಅಸ್ಟಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ 3 ಕ್ಲೋರಿನ್ ಇರುತ್ತೆ, 3 chlorines, trichloroacetic acid. In the 3 chlorines, as the chlorine is known for its high electronegative aspects, it is going to withdraw everything except hydrogens. Hence, it is more acidic acid. That is called as electrostatic or polar effects. So in PVC also you can observe the polarity because of the chlorine. So someone asks you to identify the polarity. You can identify the polarity using what are the molecules present in the chemical structure. Coming to physical, you have melting points, boiling points, solubility, and spectra. But as far as the polymers are concerned, you have TG, glass transition temperature, and TM, melting temperature, crystalline melting temperature. TM is always be for melting temperature. I told you, I showed you the polycarbonate sheet where it is transparent. If you want a material to be transparent, it should be amorphous in nature. If it is crystalline nature, definitely there will be crystal structure inside where they scatter the light. So this is E is equal to H mu also important here whenever you talk about clarity, light diffractions, or anything like that. So here in the physical properties, as the polymers are concerned, we have TG and TM. Both are very M. TM is going to tell you about the crystal structures or crystalline areas available in the molecule. So you can see here dimethyl ether minus 24 degree, whereas ethanol boiling point is 78 degree. So definitely you say that this is the molecule which have got a very good hydrogen bonding aspect. Hence the structure also determines the boiling points. The molecule of alkyl having ability to hydrogen. Similarly, when you talk about nylon, nylon has got higher temperature, higher Tg. That is because of the presence of hydrogen bonding. This also I told you about nitrogen, why nitrogen you should use for air. So this is a natural rubber. There was a new thinking about natural rubber because of the double bond. As you know that where there are double bond, there are p orbitals. So any external molecule coming, suppose oxygen, it is going to act with the double bond or the p orbital present. So hence people thought of producing a different molecule like butyl rubber. As you know that butyl rubber is the one component which is used for tubes. Most of the automotive tubes are made by butyl. That is also known as IIR, isoprene butyl, IIR rubber. You can see here. You have isoprene, iso, methyl also. Both you can see here. Methyl groups. IIR. So this IIR rubber is butyl. Since butyl rubber has got unsaturation far away, there is no chance of any oxygen or any other external agents attacking them compared to natural rubber. So polyurethane, I will just tell you one thing about polyurethane forms isocyanate groups. So you can see here, this is a polyurethane foam. You can see like this, but even when you squeeze it, it comes back to its original position. Hence, they call it as memory. Memory sponges are a material which retains its dimensions. Retain it. You can see here how the polyurethane is manufactured, and sometimes polyurethane used for skating purposes. And we have terylene, poly used for, and toluene a polyester, so repeating units. And the most important is our polyphenylene sulfide. So polyphenylene sulfide is coated onto our non-stick tawas. Before that, it is coated with Teflon. As you know that polytetrafluoroethylene, they coat this with Teflon, and polyphenylene sulfide has got a high heat resistant properties. So these heat resistance property is available due to the presence of sulfur linkages in that, and also, as I told you, benzene. As far as the benzene is concerned, the aromaticity and the aromatic characters are going to put the material in a top end. So you can see here polytetrafluoroethylene. Already I told you about that. The most slipperiest material available or made by man is polytetrafluoroethylene or Teflon molecule. So they usually it is measured by coefficient of friction. The coefficient of friction is very less, 0.05, slipperiest material. Now we have BAM as a coefficient 0.2. But usually Teflon is used, as you seen in the previous this thing used here. And the molecules are being, you can see here, it is helix, which a little bit of twisted, so that we have almost 6 molecules around a carbon. You can see in the picture I have shown 6 and molecules, so that the structural unit remains stable. So that is what being seen by vibrational spectroscopy. And this is, hope you understood some of the aspects of structure and property relationships. So chemical properties, you might have seen oxidant state, chemical bonding, coordination number, heat of combustion, reactivity, corrosivity, flammability, and toxicity. So all these things, I think I have covered a little bit. So chemical properties are also, and last one I didn't tell you is about biological properties. So when you talk of biological properties, we have odor, color, taste, drug action, toxicity. So sometimes why vanilla tastes so different than chocolate? Why do you perceive the color of banana as yellow and orange? Different molecules, because of their structure, fit differently into the biological receptors present in the living systems. So consequently, causing different neural responses. You can see that the biological properties are actually a subset of chemical properties in which at least one of the interacting chemicals is a biological chemical, such as an enzyme. So biological properties are also most important aspects. Hello?
Hello, sir.
Hello, madam.
Hi, sir. Okay.
ನಿಲ್ಸಿದ್ದೀನಿ.
Okay. Thank you, sir. Any questions? If any questions, you can unmute and ask the questions. Okay. Think no questions from audience.
No problem. Hope if they have understood something, I am happy.
Yes, sir. Sure.
Uh,
Thank you, sir. Thank you very much. It's a very informative session. Thank you, one and all, for joining us.
right, madam. Thank you very much.
Thank you, sir.
Thank you very much for the opportunity. Hope it will be useful and